I am Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about the computer network subject, in which the topic is OSPF. That means Open Shortest Path First. The outcome of the OSPF is, it is a link state routing protocol. That means now, with help of this link state routing protocol now finds the shortest path. Optimal path can be found by using the different algorithms. The one of the algorithm, best algorithm is a Dijkstra algorithm. By using this Dijkstra algorithm, finding the optimal path, that is a shortest path. So generally, it supports hierarchical routing with the different areas, networking areas, and which ensuring the scalability and fast the convergency in these different localities or different areas. These open shortest path first uses the multicast updates for establishing the efficient communication between the two other devices, which is the supporting now authentication for the providing more the security over the network. Generally, these OSPF now, it is widely used in a enterprise networking due to its reliability and flexibility of the network, whatever the network we are utilizing. Introduction to OSPF. OSPF, that is Open Shortest Path First. So it is a link state routing protocol. That means now, which is a link state routing protocol now, what it is doing now with linking the number of routers over the same network or different other networks. By linking all the networks now, which is the finding the shortest path from one router to the another other router, is used to find the best path between the source and the destination routers, using its own shortest path finding algorithms. Different shortest path finding algorithms can be used. Best shortest path finding algorithm is a Dijkstra algorithm. By using this, the Dijkstra algorithm now finding the shortest path, the same network or different networks. Here is open shortest path first, which is having the linking the number of other routers over the other network. And so these linking the services can be provided based on some set of rules. That is a routing the routers rules. That is now OSPF the routers rule. So it is an area, is a group of other continuous networks or routers can be connected. So in this OSPF, number of other routers or number of these other devices now that will be connected for providing the communication service. These routers, it may be belongs to the same area. So that is a bounded router. If it is belongs to the same area within this other locality, that routers now we are saying it as a bounded routers. So if it is the bounded routers now, which shares the same topology, that is a common topology tables. These are the common topology and the tables now, which is maintaining the different other topologies. That means bus topology, ring topology, whatever the topology we are going to constructing these are the routers for providing the services. And also area IDs. Area now for each and every networking area, while utilizing these open shortest of the path of the services now, are they giving the area IDs. That is ID 0, ID 1, ID 2, number of other IDs depends upon the area, the utilizations now. So you can give the area IDs. These area IDs that should be associated with the routers interface. Routers are the interface now, it will be associated. That means now these routers interfaces with help of these area IDs and interfaces. Now connectivity can be established between the one router to the another other router over the same network area. As a router that can belong to the more than one areas also. That means the same routers now we can utilize the more than one router, that is outbounded routers. If it is belongs to the same area, we can say it as a inbounded routers. If it is can shareable, that is a shareable routers, we can say it as a. So this is a simple the diagram for the OS the POF, open shortest path the first network the structure. Here is the number of routers. So this is area 0 network, and so this one is the area 2 network, and this one is the area 1 network and area 3 network. In these the areas now a number of the devices can be arranged by making the arrangements of the number of other devices. With the help of this the routers now the communication can be provided. Here is now internal routers and this the backbone router. So this is the bounded routers. So that is a backbone router. Now it is the backbone routers now which is applicable within this area with this whatever the devices are connected within this area now. So these the routers can be established the connections to the in this area, that particular bounded area only, bounded area devices only, and providing the services to that the devices only. This is a internal router, we can say it as a internal router, and also the backbone of the router to this other network. Here is these routers are the common routers. Now with these routers now these are the if you take this router now router 4 can provide the service to area 0 and area 2, and these routers also this is the common routers. These are the common routers now which is providing the services to area 0 and area 3. That means now these here also R2 router, R3 router, R4 routers. These are all the common routers now which is providing the services to the multiple area. That means whatever the devices are having in area 0, so that will be communicated with the area 1 devices. Why? With help of these the common routers, connectivity can be done to the both area of the devices. This is the structure of the open shortest path first. Here is the rules. That means the router rules now they are for different. Here is the backbone router. In this now backbone router now, which is the area 0 is known as the backbone router. That means this is backbone router means now the router is located inside the network now, which is the providing the service to that the particular area only. So, and the router in this area 0 are known as the backbone router. So this is the backbone router. If the router is exists partially in the area, that means other than also it is the backbone router, the internal router. Internal router means now an internal router is a router which have all of its the interfaces in a single area. That means now in this the single area 0, which is whatever these the devices are connected to this router now, which is having the interfaces to all the devices, whatever the devices are connected to this the router now, which is providing the interfaces to all the other devices. Now that other routers now, which is saying it as a internal router now, which is providing the service to that the particular area only. Wherever it is the router is located now, then that the particular area only which provide the service. Area boundary router, ABR. Here the area boundary router is a ABR. ABR, that means the router in ABR, the router now which connects the backbone area with another area is called as a area bounded routers. So here it is a area boundary router. It is a area boundary router. Now which is connecting the backbone router and other routers. And here also this is also area boundary router. Why? Because now it is connected to the backbone router and other routers, and it is also connected to the backbone router and other area networks, other routers. So these type of the routers now we can call it as a area boundary routers. It belongs to the more than one areas. So those ARBs now, which belongs to the more than one areas now, and providing the service to more than one areas with help of these ARB routers. So maintaining the multiple links state databases now that describes both the backbone of the topology and the topology of the other areas. Other areas of the topology also we can maintain. If you see area summary border router, ASBR. ASBR means now when OSP of the router is connected to the different protocols like EIGRP and border gateway protocols or any other routing protocols, then it is known as a area summary bordered the protocol. That means ASBR protocol whenever it is connected to the border gateway protocol. So we are seeing it as a area summary border of the protocol. This area summary of the border of the protocol now. So which connects to two different area summary borders. Now this is one area summary border. So this one is another area of the summary border. Now this is another area summary of the border. Now here is known as the area summary border routers. So these are the routers now which is connected to 192.168.10.65 IP address by 29. These are the device. With this other device now, these are the device 192.168.10. There is a 10.65. This is the IP address of this other device now. So it can be connected with help of this interface FA0x0 interface. FA0x0 the interface it will be connected, and also now it is connected to 10.225.225.81.30. That is 81 is the device one now. The border device is 80. So this is a device number 81 is a device number. The border now we can say it as a 80. So which is connected to 10.255.80 system. Whatever the system, the IP address is there now, which is that the system now it will be connected. And also now it is connected to 81. 10.255.255. The 81 system by 8081 system now. So it will be connected now with help of the interfaces FA 0x1. This is the interface. With help of the interfaces now in this locality area now, that devices also it will be connected to the multiple other devices. That is the area border devices. Area of the border other devices. So now which is the different other protocols, by using these the different protocols and gateways now that will be connected and providing the other services. This open shortest path first the network architecture generally now which is having the different areas, that is a backbone area. Now the area 0 here we can say area 0. This area 0 now we can see it as a backbone. Here we can say it as a backbone area, that is a area 0. That central area that connects to all other areas. That means now whatever the area network now which is connecting to all other area networks now, that area networks now we are calling it as a backbone area. Whatever the router now which is located inside that by the particular area, from that now which is connecting to all the routers which is having in a different areas, that is a backbone router. Backbone of the router. Here the regular areas means now additional areas, so that will be connected to the area 0. Whatever the additional areas are there, if it is connected to the area 0 now, that is a regular areas. Now the additional areas so that will be connected to the area 0, we are calling it as a that also regular area. That means now any networking area that should have to connect it to the backbone area. So that is mandatory for open shortest path first. Then only the shortest path, the optimal path can be find. Whenever it is connected to the backbone area, then only you can finding the shortest path. It may be the regular area or backbone area. Other areas now should have to connect it to the the backbone area, the networks. Then only here the shortest path can be find. Sub areas now which do not receive any external routers to reducing the overhead. So these are the other sub total other stuff by the areas are blocks all the external routers and the internal area routers. That is a total sub by areas. Here OSPF are the packet types. Generally open shortest path first now. Different other packets can be utilized here. Hello packet now what it is doing now, which is discovering and maintaining the neighbor relationship. So that means now whatever the routers or whatever the devices are connected here. Now this other hello packet now which delivering the the nearest the routers now which is sending these other packets now, maintaining the nearest routers. So here is this is the hello packet, and next type is a database description of the packet. That is a DBD packets. DBD packets mainly which is link state database, providing the service to link state database. Whatever the routers are connected with the links, different other links now. For that only here these are the packet delivery can be sent. That is a database or particular the student or particular the employee database. So that can be either transferable. That is summarizing the, so finally now what it is doing now, which is summarizing the link state databases. Link state database. The state 1 having one database, state 2 having another database, state 3 having another database, state 1 having the HR department database, state 2 having the some administration department database. Like this, no number of states having the database. Each and every the database that can be interconnected or linked with help of the DVD and the packets. Now sending the transparency, the messages can be the transfers. That is a link state request. That is the LSR of the packets. Link these LSR of the packets. Now what it is doing now, which is requesting a specific link, specific state link. Specific state link means now, so that is LSR now, wherever you want to send. Wherever the data you want to send now, for that the specific the device now which is establishing the link and providing the services to the database state. And link state update, LSU, link state update means this is another type of the packets. These packets now what it is doing now, which is containing the updated link state advertisements. That is a LSA, updated link state advertisements. This type of the packets. And link state acknowledgement can be sent whether whatever the states are linked, the packets are received or not, sending the acknowledgement. If it is received or sending the acknowledgement to the its surrounding neighboring routers. That is the, so with help of this link state of the acknowledgement of the packets now we can send the acknowledgement to the whatever devices are connected to the surroundings. Now we can send the acknowledgement to that particular the device. That is the acknowledgement received by the acknowledgement state, that is the LSA, acknowledgement state link state acknowledgements. Here routing process. How can you do the routing process? Generally here OS are the PF, that is for finding the open shortest path. The first now generally the routing process is very important for delivering the messages through the optimal routers. Here what we are doing now, neighboring discovery. Neighboring discovery now what it is doing now, routers now which is establish the adjacency. That means whatever routers are adjacent to that the particular router now, first the established connection can be established to all the adjacent routers that will be connected to that particular node using the hello packets. Using the hello packets. With help of these hello packets now, sending the information to whatever routers are to its the neighbors now. If the neighboring routers are received this hello packet now, so the connection can be established and sending the information to all the nodes now, and by sending the information to all the nodes, finding the shortest path. database of the synchronization. Database of the synchronization of what it is doing now, which is exchanging the topology information. That is maintain the topology table. So in the topology table means different types of these topologies are using for establishing the communications using the LSS. So here it will be maintained in a topology at the table. That information can be maintained in topology tables, and each and every router having this the topology table and exchanging the the routing the information from one router to the other router. That is a database synchronization now, exchanging topology information whatever it is maintaining using the this LSS. Here is the shortest of the path of the calculations. Next the processing now, what we are doing now after database of the synchronization now, that is a database means now which is exchange, data exchanging can be done in database. Neighboring discovery, that means what we are doing now, all the whatever the available neighboring nodes is there, that will be connected. All the neighboring nodes will be connected, and so shortest of the path of the calculation can be done by using the different shortest path algorithms. Now best algorithm for finding the shortest path is a Dijkstra algorithm. So it is a best algorithm. With help of this best algorithm here in a networking now, best shortest path can be find through these the networks now. Via that the best shortest path now, the optimal path now, the transformation can be done. The information can be transferred with the help of the shortest path. And computing the best router. Best routers now, finding the best routers for shortest path. And the routing table, every router now, what we are doing now, updating the routing tables. This routing table which is having the entire transformation details from source, what are the information is coming, and which with the destination, what is the IP address of the source, and which destination we are going to transferring now. That the routing table now which is updates the routing table. So with this shortest path, with the help of this the shortest path now, the routing tables can be updated. And the comparison with the open shortest path, the first now with the routing and the information protocol. Generally in the communication now, we are using routing information with the protocols, RIP protocol. So if you compare this RIP the protocol, OS the PF the protocols are the best of the protocols. Type of this services means the feature is a type. Type is a link state protocol. That means one state to another state now, one router to another router now, we are providing the link. And it is a distance based RIP the protocol is a distance based protocol. Depends upon the distance now, the link can be established, the communication can be provided. For that now, the algorithms are Dijkstra algorithm can be used for the OSPF. For finding the best the path. And the RIP means now Bellman-Ford algorithm can be used for finding that one. But Bellman-Ford algorithm is a very slow algorithm. Very slow algorithm comparing with the OSPF, comparing with the Dijkstra algorithm. Dijkstra algorithm is a very fast algorithm now, which is finding the best and effective path from the source to other destinations. And the matrix used. Here is now in terms of this the cost. Cost means now very high cost in OSPF, and RIP is a very low cost. Cost is very low, and scalability, reliability also very low, and scalability is a very high in a OSPF other protocols. Here is now, so updating means now the routers, the routing tables are, so only when a topology are changes now, OSPF is that means if it is a mesh topology, now these OSPF routing table can be updated. Updating the routing tables. Here, if it is not changed, the topology is not changed, networking topology is not changed, so which is not updated, the the topology, routing topology, the table is not updated here. But in a RIP, the routing information of the protocol now, suppose if you update or not update now, every 30 seconds now the table will be updated. The routing table here, the routing table will be updated at each and every router now, which is maintaining the routing table now, which is updating every 30 seconds. Every 30 seconds will be updated. So this is the main the difference between the OSPF and RIP the protocol. Generally the features of this OSPF are Dijkstra algorithm. Dijkstra algorithm, by using the Dijkstra algorithm, finding the best path and the shortest path can be found in a networking. By finding the best path and shortest the path here, data transparency can be sent from the source device to destination device very effectively. And next feature is the linking mechanism can be used. Link state and routing protocols we are using the LSRP. So this linking mechanism now, so easily finding the neighbors, easily finding the best path. Best path can be find by exchanging the some other messages, exchanging the information messages between these neighboring nodes now, neighboring routers now. Here easily you can find the best nearest path. The new that is and about this network the topology, what type of the topology is using. By linking the process to the nodes now, easily finding the best path rather than the entire routing table. So this is a link state routing protocol is another feature. And here hierarchical routing with areas. So by arranging the areas in a hierarchical structural form, effectively we can find the best routing can be found. Dividing large areas into the sub areas now, and the tokens it will be divided into the tokens, and that is in the form of the tree, which is construct the area of the networks. One area 0 is networks, area 1 network, area 2 networks now in the form of this hierarchical form. In the tree structure form, it will be represented. By representing the tree structure form now, best and effective path can be defined. The path is possible or not now, we can find the path. The possibility also now we can find. And reducing the processing overhead. So suppose the processing overhead is now more data is transferring for processing is not possible. If it is complicated processing complicators are existed, now that will be which reducing the processing overhead also that can be reduced by limited route propagations. Routing propagations will be by limited here, and overhead more data transparency can be reduced. Multicasting routings can be updated. That means multicasting routing, with a multicasting routing here, more information, more data can be sent from the multicasting address here. This is a all OSPF routers, and so this is a OSPF designated routers. That means source router address, IP address, and destination IP address for efficient communication now, which is all for all. That means for all whatever the devices are connected over the network now, all the devices can be interconnected and assigning the one IP address. Here also all the devices are interconnected and assigning the one IP address for efficient communication now. By this now, casting routing updates can be done regularly, and fast convergency can be done. So this is another feature. Why? Because now the updates quickly updating the this routing table can be updated very quickly. Very quickly, if any topologies are changed, when the network card changes, so immediately updates can be done. So by updating these the topologies and the routing tables now, the efficient communication is possible. Your load balancing can be done. That means load balancing which supports the equal cost multipath routing. So with equal cost cost multipath routing here, whatever the data is the network is which is the loading, so which is having this capability of the network now, that much of the data only we can transfer from the one router to the another router. So by effectively now, without the congestions now, without overloading here, the load balancing can be done with help of this OS or the PF the technique. The conclusion of this OSPF is an advanced routing protocol. It is widely used in the enterprise networking due to its the efficiency, scalability, fast the convergency. So it outperforms the routing the information of the protocols. So better than now OS the PF, which is performing the communications better than the RIP protocol. So in a larger area of the networks, different collection of this area of this networks now, OSPF is a better service can be provided, providing the load balancing and the hierarchical designing and security other features can be provided. security other features can be provided. So it is requires the more CPU and memory other resources. Now it is making it very suitable for the medium to large scale of the networks rather than the small scale of networks. Here is now generally these OS the PFs are used for the large area of the networks for the better performance and accuracy and for better the communication. So this is about the conclusion of the OSPF. And for this other topic, the textbooks are the Foreign Data Communication and Networking, and the Tenenbaum, S. Tenenbaum, Computer Networks, and the 5th edition 2010. So these two textbooks are the better for the open shortest path first. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.